are we okay with the analysis? Calling it, you know, that's the distribution. We got the distribution dialed in. Totally fine. Good. Happy. Okay. Trees, ask me that question.
Oh, no, I was just stretching.
Oh, you were just stretching. Oh, okay. I'm sorry. That explains the pained look. I thought it was statistics that made the ouch. Okay, good. That's okay. As long as it's muscle, we can stretch that out. Good. So let's buy a second bird. Flock number 2. Yes. 2 birds. So Max now has a box with 2 birds in it. And how many girls could be in the box? 2. That's what we hope, right? What else could be in the box?
1.
None? What else could be in the box?
1.
A boy and a girl. Yeah? Poop. So a number of girls in the box. Might be none. You might have 2 roosters. It's possible. It's possible. You might have 1, you might have 2. How likely? And again, this is where it comes down to measuring that likelihood, right? How likely is either any of these events? Grab one and tell me how likely. Pick one of them. Pick anyone. Think back to your last project and also what Aaron said earlier, because he's actually given us, I think, a really beautiful way of looking at this. Pick anyone you want. What do you think? 2. 2 roosters or 2 chickens? 2 chickens?
2 hens.
2 hens. What's the probability, Tom?
0.1.
Why?
Because it's 0.9, it's 0.9.
The chance that Max got a girl on the first pull is 90%, correct? So we know there's a 0.9 involved. We know there's a 0.9 involved. Now remember what buying 2 birds means. He goes in and grabs one, and then he buys another one. Bought a bird, and then bought another one. What does "and" mean? Multiply. That's your last project. That last project, as traumatic as it was, I apologize for the trauma. As traumatic as it was, the big idea was that "and" means to multiply. He is buying 2 girls, or he's buying 2 birds. That means, what's the chance of getting the first one be a girl and the second one being a girl? Well, that's the chance of 0.9 times 0.9, which is 0.81. It went down. Why would it be less likely to get 2 girls than 1 girl? Why wouldn't it go up? Because every time you grab a bird, it's uncertain whether it's a girl or not. Think of it this way. This might help. Imagine a coin, heads and tails, but heads comes up 90% of the time and tails comes up 10% of the time. It's rigged, it's a fixed coin. Every time Max goes into that thing, he has to flip the coin to decide what the sex is. So there's always that chance there's going to be a boy. So it's uncertain with every passing bird bought. That's going to keep going down. It has to, because you're less and less likely that they're all going to come out girls. Back to your 10 flock moment. I'll stop talking about it again. But that's the idea. Good, 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 good. What else goes down, though? On the good side of the coin, the chance that they're both boys. What's the chance the first one that he grabbed was a boy? Only 10%. What's the chance once he grabbed the boy that the next one's a boy? Which means there's only a 1 in 100 chance they're both boys. Now you gotta realize what that means. That means if I send Max, now this is gonna sound stupid, but if I send Max in that store once a year for 100 years, this is dumb because he's not Yoda. Once a year for 100, kind of looks like he's adorable. On average, one of those 100 trips, he's gonna come out with 2 boys. Now, spreading it out to something more realistic, for 100 people that have gone into that store, because what happens is they keep replenishing those day-olds as they get sold. For 100 people going in and buying 2 chickens, one of those people is going to come out with 2 roosters. You know, and then they get pissed because they get roosters, right? But statistically, it's going to have to happen. It has to happen, right? That's the thing about this. We're measuring the uncertainty now. Okay? So what's the chance of getting one of each? Yay! Just like Hawaii. No, wait. That's Tom. I heard a 0.18. Tom says 0.18. Do you agree? Why?
It's what's left.
Because it's what's left. So you know that the probability has to sum to 100%. So we don't even have to mess around with these 0.9s and 0.1s if you don't want to. We can just go straight to 18%. It's whatever's left.
So how would we get it from
Yeah.
Well, how would we? I wasn't going to go there, but thank you for going there. How could we have gotten that 18% without knowing the 81 of them? John, go.
Add the 2 and divide by 1.
Add the 2 and divide by
Or
2.
subtract it from 1.
Well, I think that's what we did. Because we did 1 minus that, and what's left is 18%. But I guess the question is, suppose we didn't know those.
Oh.
How could we have gotten that directly? I think that's the question, right? I think. What do you think?
Multiply them and then multiply them.
What are you thinking? Anna, you said multiply.
Yeah, I was gonna say what you said.
Go ahead, say it, Anna.
Just multiply like 0.9 times 0.1.
Oh, I love that, right? Because 1 means 1 girl, 1 boy.
And then times 2.
Why would you times it by 2?
There's 2 ways to get.
This is where it gets interesting. This is why I'm slowing this down.
There's like
Boy, girl.
Yes! That's, thank you for that, for making the connection. That's the connection. So let's slow down. Let's slow down. 0.9.1 is 9%. That's exactly half of what it should be to get to 18%. But you gotta remember something. I'm gonna come back to the 2 dice in a second. I love that you said that. It makes me so happy. Here's the flock we just bought, 2 birds. Now, if they're both girls, that means Bertha's a girl and Nancy's a girl. End of story. That's the only way you can have 2 girls. If they're both boys, that means Bertha's got to be renamed. Bertha's a boy and Nancy's a boy. End of story. If there's 1 girl and 1 boy, another question gets asked, isn't it? Which is the girl? It might be that Bertha's the girl and Nancy's the boy. Or it might be that Bertha's the boy and Nancy's the girl. So realistically speaking, what's actually going on in the calculation, sorry about that, that's a little bit loud. What's realistically going on is Bertha's the girl and Nancy's the boy. Or, which means add, Bertha's the boy and Nancy's the girl. And that's the other 9%. Hopefully that makes sense. If that doesn't make sense, Anna has given us a beautiful remembrance of last week to give us another way of looking at it. Go ahead and say it again, Anna, if you don't mind.
the dice, when you could get like a combination of 6, it could be like 2 on one, 4 on the other one, or 4 on one and 2 on the other.
Last week we were playing with the dice in class when I had you guys dice and I said, make snake eyes. And you went 1 and 1. And I said, excellent. I said, make snake eyes again. And you said, the hell with you, I can't. Yay, you couldn't. Because a 1 and a 1, you can't move it around and make another 1 and a 1. That's kind of like having 2 roosters or 2 hens. You can't turn the dice a different way. But if the numbers don't match, say when I said make 3, and you guys went 6, let's go with 6, I like that. 6, you went 2 and 4. And I said make 6 a different way, and you turned the dice to different faces and went 4 and 2. That's Bertha Nancy, Nancy Bertha. That's like turning the dice. The sexes are different. One's a girl, one's a boy. Assignation of the sexes, therefore, can happen in 2 different ways. Thank you for the beautiful parallel there. Hopefully that makes sense. I love the die comparison. That makes me happy. I love when students reach back to that. That's good. It's why I do it in class. Just put that in your mind for later. I'm glad you made the connection. Cool? Is that fair? Maybe? We're going to keep building flocks as we go through. And we'll still get you guys out here early, I promise. Promise. Cool? How many girls would you average if you keep buying 2 birds at a time? I'm going to bring this variable back, if it's okay with you. Mu for average number of girls. I want to get you used to that, especially you guys go to 244. That's just the population average of girls. I can call it that because I'm putting a hell of a lot of faith in that 0.9 the guy told me at the store. And Gail, you've been told that number too? 0.9?
No.
Oh, you haven't? What have you been told?
I never really asked.
Oh, you never asked?
I never asked.
If you think of it.
The exact. They just say they're usually going to be mostly girls.
Ask him to define what usual means.
Yeah.
And what mostly means. Huh? Yeah. Make him metric it.
I've heard numbers
They love when you
higher
do
than
that, by the way.
0.9.
What's that?
I'd say I've heard numbers higher than 0.9.
See, I haven't yet. I've heard people say that to me. I've had most people agree with the 0.9.
Like at your average feed store, for you buying 3 chickens, whatever. But if you're buying 10,000 chickens, you don't want 1,000 roosters. Like,
No, you sure don't. You sure don't.
There's some people that make really good money sexing chickens.
Yeah, which makes me wonder why it's not higher than 0.9. Maybe it is,
Well, that's why.
but maybe we're getting from a different distributor. Who knows? I mean, who knows why? We'll come back to that. You're taking 244, right? Yeah. I have a great little quiz set up to discuss that exact idea. Yeah, we'll come back. It is.
I'm sure we will.
Oh, hell yeah. Yeah, chickens are great. Chickens are great. How many girls on average you're going to get? Can we calculate it? Say it again. Why 0.99?
Because you're adding up the check.
Let's do it. Let's do it, right? So we take the data, 0, times probability, 0.01. So
Or no, it's 2.
yeah, you got it, brother. You got it. It's good. It's good. The true rooster case is contributing nothing towards the average, which hopefully makes sense. We're talking about the average number of girls, not boys. Hopefully that makes sense. Plus, now we can have a 1 case, and that does have a probability. So now that's 0.18. We're getting 1/1800ths of a girl added into the average from those occurrences, right? It happens 18% of the time. That's fairly high. That's fairly high. So right now we're like, oh crap, roughly 1 in 5 times we're getting a boy in that box with the girl. But then we put our minds at ease because the 2 girls happen 81% of the time. So roughly 4 out of 5 times you're getting both girls. Roughly 1 out of 5 times you're getting a boy and a girl. And usually never you're getting both boys. I mean 1 in 100. It's a pretty small probability. But this is no longer small, is it? 18% is pretty big. That's 1 in 5. That's a lot of potential roosters. What does that all add up to be? 1.8 girls per flock. Now, hopefully, this ties in with my diseasedness, the way I look at these birds. I look at the bird and go, 0.9 of a girl, 0.9 of a girl. If Max grabs 2, that's 1.8 girls, right? 0.9 plus 0.9 is 1.8 girls. Hopefully that makes sense, like on an intuitive level. You add another bird in the flock, you add only 0.9 of a girl. You're not adding an entire girl. It's a terrible way of thinking about it, but it's a realistic way of thinking about it, especially when you spread it out to large flocks, especially in that case. Fair? You guys buy that? Ask the questions if you have them. Ignore the standard deviation. I don't care about it. I don't care about it anymore. This is going to be such a skewed distribution. The standard deviation doesn't mean anything anyway. It doesn't tell us anything meaningful. The average is then therefore skewed a little bit too. But the average, because so many chickens are sold, the average is a good, meaningful indicator of what's actually happening in the long term. So I kind of do like to look at the average. Yes? We okay? You guys need a break? It's 11. Need a break? Keep firing through. Finish a little bit earlier. I usually don't like doing that, but I also want to get you out of here before it starts doing anything worse. So just fire through. Is that okay? I usually don't like doing that, but if you guys are okay with it, okay, we're okay with it. All right, here we go. Flock number